All right, it's recording.
Well, welcome to the May 30, well, actually, it's June 1st UTC session of TangerineSDR and Ham-Sci technical session. My name is Dave, KV0S, and this week I've been doing some cleanup around the shack and getting out all my old radios and testing that they actually still work, and getting some radios I've never used, but getting them set up to work. So I have a whole lot of new to me radios to play with. And that's it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you, Dave. Well, one of the most exciting things for me was Jonathan KC3EEY came over to my house on Friday, and he brought over some toroids that I desperately needed to clean up some RFI that was on the computer-aided tuning CAT system for my IC7410. And so we got that put in, and now I can actually transmit, and my CAT system keeps working, and my antennas, my power doesn't go out, all sorts of things work. So I made a few QSOs in the CQ World Prefix contest this weekend. My CW is terrible, but I did it anyway, and that was fun. And tomorrow I'm starting a new the summer research program with about 8 students. So it's a new schedule, and we should have, I'll want to talk with Dave, KV0S, and Scotty later, because Kung is going to be coming back, and I'd like to have him work with you on the FPGA stuff.
Yes.
So Kung is going to be one of the students that's hired this summer to do work. So, and then Majid is a staff member. He's going to be working on the magnetometer stuff. Scotty is sending me a new set of magnetometer boards, which should be arriving hopefully this week. All right, W2NAF, back to Nat.
Well, fine business. And next on the list is Dave, KD0EAG. Go ahead, Dave.
Hello. I've been madly trying to put together some documentation on using the software for the magnetometer and all the associated uploads to to the cloud instance, and various other things, trying to get it all in one document and intelligible. But I just discovered a bug a minute ago that seems to be preventing it from auto restarting when the Pi is rebooted. The software was never ever intended to be the main stream running software for this purpose, but I guess time is marching on, so I'll get this documented and solve this last little problem, and it can hopefully be a little useful to somebody. That's it, as far as I can remember. There probably was something else, but I don't remember what it was. Over to you.
Fine business. And next on the list is Dev, KC3PVE. Go ahead, Dev.
Hello, good evening, everyone. So I took literally a break during the weekend, and I'm trying to catch up with the to-do lists that I had made before the break. So I think I don't have more specific updates. Thank you.
Very good. And next on the list is Bill Kelsey. Go ahead, Bill.
Yeah, I don't have too much to report here. I've been busy all week with getting the boat ready to go in the water, and so I haven't even been at home. And today and yesterday was down with the grandkids in Columbus and up here. So I'll just sit and listen tonight.
Fine business. And next on the list is David McGaw. Go ahead, David.
Hello, everyone. I've missed a couple of meetings, but I was down at Wallops for rocket launch. It was successful.
Yay.
And you can catch it on YouTube if you wish. It's the Viper mission. Yeah, we saw a lot of signals from that rocket. It was a radio experiment, primarily picking up NAA, VLF, 24 kilohertz, but I was flying a HF experiment, and I was surprised to see the AM broadcast band. When we fly from northern climes, Alaska or Norway, I didn't see this. And then I saw a forest of lines as we were flying and said, what is that? And then I looked at the frequencies and said, oh, that's AM broadcast. They were coming in loud, but as part of the experiment, they were loud as we went up. And then as we went through the ionosphere, the level dropped right off and then came back as we came down on the down leg. We only went up 100 miles. This was just to get out of the VLF waveguide, just enough to get out of there and then come back in. And looks like we had a successful experiment. So that's what I've been up to. Back to net.
Very good. And next on the list is Gary. And what is it? Go ahead, Gary.
All right, Dave, thank you very much. Good evening, everyone. I know I've been AWOL from this and the Thursday meetings for a couple of weeks, dealing some issues with the new house and also helping a lot of friends here in the Northern Ohio area recover from antenna problems that Mother Nature put forth over the winter. So glad to be back and back to net.
Fine business. Next on the list is James, KG4 DSG. Go ahead, James.
Good evening, all. Just listening in as usual, and I've got 20 years worth of audio cables spread out across the floor that I'm trying to sort through. So I've got my project set for the week. Back to the net.
Well, fine business and have fun. Next on the list, we have Jay, WB8 SBI. Go ahead, Jay.
Well, howdy, everybody. And first, most important thing, since today is a holiday, thank you to all who have served and are serving, and let us remember those who served who are no longer with us. And when the roll call is called, that we must answer present on their behalf. Ham radio wise, not a whole heck of a lot. I'm still accumulating my surface mount tools and surface mount equipment and I have a practice board to learn how to do this. Studied some YouTube videos. So before I actually start to work on the real boards, get some practice time in and learn how to do it right. So still accumulating my surface mount toolkit. Other than that, I heard on FT8, I heard Turkey, and I actually heard the South Pole on FT8, but both of those were one and done events. You know, you hear them once and that's it. You don't hear them again. So other than that, it's just been a nice holiday here. That's about all here from the northern suburbs of Detroit. Back to net control from WB8SBI.
Fine business. And let's see. Next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, Dave, and everyone else. Been mostly paying attention to the grape receiver and how it's receiving 10 megahertz WWV. Not getting very many fluctuations, especially in the wee hours of the morning. And I suspect I'm getting interference from my local 10 megahertz standards. And right now I just turned off some of that. So we'll see what happens this evening. But the trace has been much less volatile than it was a month or two ago. And Nathaniel, I help out with a digital net on 20 meters on Saturday morning, and the CW contesters were just all over us. They don't seem to understand that there's such things as digital nets that take place. So anyway, and sure glad you got your RFI taken care of. Thanks, Dave.
Fine business. And next on the list, we have John Ragland. Go ahead.
Good to see everybody. I hope everybody's evening is not bad. And I have no traffic for the net.
Well, fine business. Thanks for being there. Next on the list, we have Jonathan, KC3EEY.
Hi, everybody. I had a pretty good week. I was able to help Nathaniel with his cat issues. The serial port kept disconnecting, so we took some of my ferrite beads that I had for use with my audio cables for my VLF receivers, and we put them on the USB cable and coiled them up, and everything actually worked really well. Also, I had a pretty good discussion with my or with an advisor at for graduate school. We talked about a lot of different things, and he's kind of excited about my VLF projects. And two of my classes for my undergrad could be transferred into the program, or at least he needs to see the syllabi. Other than that, that's all I have. Back to the net.
Well, fine business. And next on the list is Jules, K2KGJ. Go ahead.
Okay, guys. Yeah, interesting week. Had a good openings on 6 meters this week. As regular openings, single sideband, CW. I got parts off to and instructions off to, I think I'm pronouncing the name right, Majid. I was working with Nathaniel to build up a magnetometer, and looking forward to Dave's new software so I can get one of my magnetometers online, reporting real time on that. Other than that, that's about it for this week, and back to net.
Well, fine business. And next on the list is Con, KE8QWB. Go ahead, Con.
Hey, all. Can you hear me?
Yes.
Okay, cool. I had car problems out in the field, so I'm back in Ohio now. Spent the last couple of days reconfiguring my server to install Windows on it. It was a Linux machine before, so it took me a while. But I got it working just about this morning. Got my SDR hooked up to it. It's working. So probably the next couple of days or the week or so, I'm gonna put up some more antennas and do some more learning. But that's about it. Back to net.
Fine business. And next on the list, we have Mike, AA8K. Go ahead, Mike.
Well, thanks very much, Dave. I'm kind of trying to concentrate on my Excalibur board for the HPSDR receivers. I need to fill in the last one so I can get ready for the eclipse monitoring in 7 days. The board has no parts on it yet.
Oh.
But the other problem is I've got to clean all the other projects off of my workbench to make room to work on this one. Back to you.
Well, have fun. I think you'll be busy. Next on the list is Scotty, WA2DFI. Go ahead, Scotty.
Well, thank you, Dave, and good evening, everyone. Let's see, this week I got my Linux box set up and got the 20.1 software moved over or loaded onto it, and I was actually able to attempt a test compile of the first code for the FPGA. Still have a few bugs working on, but at least I got something that will not bomb off the RAM module. Like, I successfully compiled the RAM module with it, which is something that the Windows box couldn't do. So thumbs up to that. That's a good milestone there. Also, prepped and gave a 30-minute talk on HPSDR. I mean, on I'm living in the past, right? On TangerineSDR and PSWS to the YouTubers Hamfest, which was over the weekend, and they scheduled me for 7 a.m. Central Time, which was 7 a.m. and that was 5 a.m. my time. So it was fun getting up at dark 30 and to give them a half-hour presentation. And then I kind of fell back against the pillow because it was pretty early. See what else. Also, like I can relate to the to Jay's, not Jay's, John's dilemma of when the next project comes, you got to spend some time cleaning off the old projects. So got to spend some infrastructure time putting parts away and cleaning off the bench, getting the horizontal space. So spent a little bit of time this weekend, this holiday weekend, just getting things cleaned up and getting the space to work. So be much more enjoyable to work on the FPGA code with a desk that I can actually sit at, and I can actually see like the top of the desk. You know what I mean? You guys all know what I mean, because I can look at Dave's desk and see back there.
Yeah.
Looks like mine.
I cleared enough space to do one soldering project. But
Yeah. Anyway, that's it for this week. So back to you, Dave.
fine business. And next on the list is Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave, everyone. A couple of items that continue to work on the receiver characterization presentation for the GNU Radio Amateur Radio Meetup, and some more charts put together on Hermes, how it handles those tests. I found a significant amplitude variation in the GNU Radio FFTs, which depend on the windowing function, quite a bit more than I was expecting, leading to some unusual results. And thirdly, I sent Scotty a long email about which capacitors are the important ones in conducted noise from switching supplies, and a recommended low-cost, low ESR component that may be usable for those supplies. So that's about it this week.
Well, fine business. And I think I've gotten everybody on the list.
Dave,
So-
could I add one more thing?
Sure, go ahead, Joe.
Yeah, in the middle of the night, in other words, about 1 a.m. here, I got up and listened to WWV, CHU, and I think it's RWM, the different time stations, or at least tried to find them. And WWV comes in pretty well on all three frequencies, 2.5, 5, and 10. CHU came in well on the 3 meg and the 7 meg frequencies. I only heard little tiny bits of RWM and not anywhere near enough to copy. So anyway, I've been listening for those for the upcoming Eclipse Festival. Thanks, Dave.
Fine business. Okay, well, I think we're ready for general discussion.
Okay, I got a question for Tom on the capacitor selection. I think that diagram that you sent me shows the two capacitors just in parallel on the output, right? So there's a bulk for smoothing, and then there's an RF capacitor for getting rid of the high frequency harmonics. Is that right?
Yeah, and the bulk capacitor, it has to be a low ESR capacitor to get rid of the main switching frequency of the switcher, which is down in the 50 kilohertz or 100 kilohertz range.
Right.
And so that capacitor is the one that really needs the low ESR. The other one then gets rid of the RF.
But so are aluminum electrolytes really going to be better ESR than solid, like not tantalums, but solid ceramics up to, because I can get ceramics up to about 100 microfarad.
Yeah, when I looked for the parts, the aluminum electrolytic low ESRs were much more cost effective. You could get them in the 1,000 microfarad range very inexpensively. The ESRs I saw, the tantalums, of course, have good low ESR, and they're like $8 a capacitor. So they're way more expensive. So in terms of the big bulk capacitor, those aluminum electrolytics I found were very cost effective.
But do you really think we need in the neighborhood of 1,000 microfarad?
I don't know. It depends on the load that you have on the switcher. and, the frequencies of interest.
Yeah, it just seems like that's a lot. I mean, I'm used to maybe multiple caps totaling around 500.
Yeah, so that the manufacturer of that particular switching chip recommended 1,000 mic low ESR cap. And so I just sent that app drawing because that was their recommendation for noise.
It's always good to listen to the manufacturer's recommendation because they have a little experience.
A lot of complaining customers if they don't.
Yeah. Okay, so that may be the problem with ours because I must have missed that. I don't think I used near that much capacitance in the other design that I did using the same regulator. So we'll fix that this time around and change the caps out. So
yeah, it took a bit of chasing. The DigiKey site was not very helpful. When you searched on ESR, anytime you selected a spec for ESR, all parts everywhere failed to meet the selection criteria. Yeah, when I went over to Mauser's site, it actually worked. So I was able to find those on Mauser.
Seems like a lot of data sheets don't even spec ESR.
That's true. That's true.
So, I mean, my thought is if you don't spec ESR, then you're probably not a low SDR cap. So you're out.
Yeah. So anyway, but Mauser's site was a little more helpful there. At that data sheet was at least one part. You may be able to find that same part on DigiKey, and it may just be that their selection filters aren't very friendly.
Okay. Well, thanks for looking all that up. That's it was useful.
You bet.
I want to mention James Kennedy just joined. Well, there he goes away from his camera, but he's just joined the group. James, are you there? Nope, I guess.
He's not connected to audio yet. It says he's still trying.
Yes.
Okay. Now he's
If he
muted.
comes on, you're welcome to make some comments if you want, James. Oh,
You're muted.
still mic muted. Well, if you get that fixed, we'll just go on with the discussion, jump in anywhere you want. So let's continue.
I guess I'm unmuted now.
Oh, now we can hear you.
Sorry about that. Apparently, I was a couple of light years behind on my software. It took me a while to get it all put back together. Happy to join you.
Yes.
So it sounds like everyone is kind of enjoying the weekend and not doing a lot of radio stuff, which is good for a change.
I've been spending a little time learning about GNU radio. I hadn't used it a lot, but I'm going to try to get myself up to speed a little bit.
Well, it's definitely got a learning curve to it, but it's definitely worth it.
Yeah. I did see an interesting presentation online by a French electronics professor where he used a GR octave module to run octave simultaneously with his GNU radio setup. So he was actually using like a Pluto to in 440 to get distance ranging, and he was using that to do the filters or the Fourier transforms to get the conjugates. And it was a very interesting way he did it, and it was a good demonstration of using octave with kind of inside. He was taking the signals and passing them into octave out of GNU Radio.
So is he just scripting into Octave?
Well, there's more to it, but yes, basically, you could write to a sync, and then Octave can read the sync actively.
So it's like piping data then.
Yes.
So streaming the data into Octave, and
Yes.
it could keep up okay.
Yes, yes, it did. He was moving the signal around, and you could see in both graphs, the one inside GNU Radio and the one in Octave were moving more or less together.
That's interesting. And so what kind of machine was he running this on?
I have no idea. It was during a presentation for GNU Radio 2020.
So probably not a Raspberry Pi.
No. And he was not, I think he was a ham, but his focus was more academic.
Okay.
It was some exercises he did during COVID. He wanted to say, well, how far is that building across the street from me? And he used 440 to figure out, to do radar reflections off the building.
Wow.
Talk about interesting things to do in your spare time.
Talk about pretty low frequency radar.
Yes.
So one of the things I did this weekend was I bought 2 new 10 terabyte hard drives, and I set up the Edis USRP that I've been using to collect data for the chirp sounder, the oblique ionosons that Dev has been using. And I learned how to mirror the RF data. Right now we've been just doing a ring buffer. So it listens to the RF data, analyzes it, and then throws out the stuff after it's done. But I copied, basically an entire day to the external hard drive, and to 25 megahertz worth of IQ data in the digital RF format takes up almost 10 terabytes. So I filled up an entire 10 terabyte hard drive yesterday.
Ooh.
In one day?
Yeah, one day. And I'm filling up a second one right now. And then tomorrow morning, I'm going to hand these hard drives off to Dev, and he gets to look at the data.
So how many hard drives can you afford at 10 terabytes each?
Oh, I don't know. I mean, I can afford a few. I don't have like infinitely deep pockets here, but it's not sustainable. It's not something we can keep doing, but it is good for debugging, and it's good to know how to do. And Dev's trying to figure out how to really automatically decide whether an ionoson he's receiving is from Virginia or somewhere else. So he's starting to go more deeply into how the range gates are calculated and trying to understand that. So he wanted the raw radio frequency data. So now I can give it to him, at least for 2 days.
So what's the data rate? I could try and figure that out, but it's probably going to make my head hurt. So
I think
how fast
25 mega samples per second, I think.
But they're 16-bit samples each one, so that's 400 megabytes per second.
Yeah, I think so.
Whew. For the whole 24 hours.
No, that 16 bit words, that'd be 2 bytes per word at 25 megasamples per
16
second.
bits I and 16 bits Q, right?
Oh, an IQ, that's correct, right?
Yeah,
Nathaniel?
I think so.
So yeah, that's 100 megabytes per second.
Yeah. So it's still
pretty good
recording right now.
Yeah.
Yeah.
So what kind of drives are these? Are they just generic drives? Are they high performance ones or what?
They're Seagate backup drives. I bought them at they're the desk. They say they're 130 megabit per second transfer rate, I think. I can
megabytes.
Hold on, megabyte per second. Hold on.
By far sight different than when we were doing 100 kilobytes per second for
Kilobytes.
the early experiments in digital audio.
Oh, let's see. If
And
I
these
can
are
drive-
SATA drives, or are they USBs, or what are they?
They're USBs. I just went to Staples last night, and
So these are USB 3 drives then, and you could get a sustained 100 out of them. Obviously you can, since you did.
yeah,
Just be wary. Most drives, when they're empty, run faster than when they're full because they don't all record at the same rate across the platter. They slow down the further you go in. So you might get 150 on the outer edge, but you may get down to 70 on the inner edge.
Because the linear speed is slower on the inner spindle than on the outer.
Well, they pack the bits different.
yeah. I bought 2 of these,
Oh, okay.
so it didn't seem to complain last night. So
So what did those cost you? 10 terabytes.
$200 each.
Wow,
That's
pretty
ridiculous.
good.
Yeah, I was really happy with that because I mean I looked online at Newegg the other day, and an 8 terabyte one on Newegg was like $210, which is still very good. But then I was like, I don't feel like waiting for shipping. I'll just see if I can go buy these things myself. So I just, at first I went over to Best Buy because I thought they had them there, but they were completely wiped out. But the Best Buy is right next to the Staples. So I just schlepped myself over to the Staples.
You could go on Amazon, you probably get it delivered in one day.
Probably,
Not
well,
anymore.
with Memorial
anymore.
Day and
Oh.
this is faster. So I just
I
walk
know,
in,
I
bought
tell you
2
what,
of these. And
I was working on my furnace here, and I won't go into the details of the idiocy that I perpetrated on the furnace unit, but I burned out one of my thermostats, one of my smart thermostats. And I'm like, oh no, man, that means no air conditioning until I get a new thermostat. I got on Amazon. It was about noon o'clock. I got the thing delivered by 5 p.m., a new thermostat.
wow.
Wow.
5 hours, and they delivered it to my house.
Wow.
So it was some things in Phoenix anyway. In fact, in Tempe, I just saw that they have raised now used to be a German auto junkyard, wrecking yard. And it was, I don't know, 40 acres maybe. I mean, it's huge, big, giant junkyard. Well, they've gotten rid of all the cars and all the junk, made a flat field. They put this giant Amazon warehouse in there. I don't know how far back from the road it goes, but it looks gigantic from the road. So, and the thing is, it's like 2 miles from my house. So anything in that warehouse,
Oh, there you
I
go.
can get in hours.
That's almost as far away as my mailbox is from my house.
So Amazon does not deliver to your house. They only deliver to your mailbox because it would take an extra day to go to your
my
house.
mailbox is 3/4 of a mile away from my house. So actually UPS and FedEx will deliver straight to my house. But anything that's USPS, if it doesn't fit in the mailbox, we have to drive to town to get it.
And it has to fit in the box too, right?
It has to fit in the box. That's right. So yeah, if it doesn't fit in the box, then we have to drive to the local post office and pick
Yeah,
it up.
so we have that problem here. I mean, I live in town, okay, my neighbor is 100 feet away from me, but I have a mail slot in the wall that goes in and down and comes out into where the regular like letters go and magazines go. But of course, parcels won't fit in there. So they won't leave them on the porch unless you put a basket there that is for USPS mail, that is official delivery, and Amazon tends to use it to put their stuff in, which they should not, because the USPS gets mad about it because it's their delivery box.
Right.
But they will leave something in that. But I have a hard time getting them to just leave it on the porch. Even though there's no signature required, they still don't want to do that for some reason.
I've had the post office take stuff out of my mailbox that shouldn't be there, give me a notice of mail to be picked up, and then charge me for it.
Wow.
Stuff that isn't addressed to you?
Yep. Well, it wasn't addressed. It was just something stuck in the box that somebody was giving back to me. Post office took it, sent me a notice, charged me for it.
We had a PO box
Oh my
for
gosh.
our company, all right, and our financial guy was going to the PO box and taking the statements out, because if all the mail is for him anyway. And so I needed to give a letter to him. So I took a letter and put it in the box. This is maybe what you're talking about. I took a letter and I put it in the box for him. And the post office found it and said, you can't put outgoing stuff in that box. This belongs to us. And they charged me 50 cents for the letter, for sending the letter to my guy who just going to drive in and pick it up and take it out of the box. They didn't have to touch it at all, but they found it in the box because it didn't have a stamp on it, and they got upset. So is that what happened to you? You put stuff in there that was not post office stuff, and they...
Well, this was a power supply that somebody was returning to me. He stuck it in the post office box. They grabbed it and charged me for the weight.
to ship it this far.
It wasn't
right?
a cheap thing. Yeah, it's like, oh.
Oh my
I belong
gosh.
to a nonprofit organization.
Yeah, you got to
and
watch
every
out
year
with
we
post
go
office
around,
boxes.
we pass out things to every house in our city. And one of the things we were especially told to do is not to put it in the mailbox, because of the fact that if you, there's, I don't know if it's federal law or federal regulation, that only the US Postal Service can put things in there. And if it doesn't come through the US Postal Service, I don't know if it's federal law or federal regulation, you're not allowed to do it. That explains what happened to you.
No,
So,
absolutely. Yeah,
that's
it's
the
well known,
explanation.
but
And it doesn't matter where, or it doesn't
That's
matter what.
always been
yeah,
that way.
they're really hard nosed about it.
So the post office takes it out of your box and then mails it to you.
Right.
Puts it back in the box again, but with postage on it now. Good deal.
Yeah, so bottom line is don't put things in those boxes. Have it a separate box for other deliveries.
Well, I find it interesting because I have a PO box. I've had one for 40 years since I moved to Arizona. And if you ship something to the PO box, it's priority mail. They will. I got a little box. It's about that big, and they're always after me to get a bigger PO box. And I said, well, okay, I'll pay for a bigger box, but I want the same number, because I've had the number since 1975 and everybody knows this number and I'm not changing the number. And they said, well, we can't do that because the little ones are in the numbers up here and the bigger ones down here have higher numbers. So if we moved your box, well, and we'll forward the mail for you. And I go, yeah, right. For how long? For most of the time, you can't even get the right mail in my box alone. So I'm not going to depend on you to forward, even if it's from up here to down here. And so I refuse to do it. But the thing is, if you ship it USPS to a PO box and it doesn't fit, they will actually, they've got lockers out in the front of the post office, and they will put the thing in a locker and put the key in your box. And so you don't have to wait in line to pick it up. But if you try shipping it UPS to a post office box, forget it. And if you try to ship it, trying to think, there's some things that they won't do that with. And I think like parcel post, maybe they won't do that with, but priority mail, they will. And first class stuff, they will. Because some things they get pissy about it. They want to make you stand in line. And other times they'll help you out in a box.
Nathaniel, do you have a rural mailbox or a standard size mailbox?
I guess it's a rural mailbox.
There's a larger size that allows an 8.5 by 11 sized envelope and boxes comparable to fit in it. That's what I have.
Oh, well, maybe I think we have a standard one then.
Yeah.
But I think I can, maybe I can get around to upgrading our mailbox. It'd probably be worthwhile.
Right.
So can you get can you build something big that would take a package?
I guess so.
That they would put the package in?
Well, that's an interesting thing too. There are legal mailboxes and you have to buy one of them, but you can build anything you want around it.
I think, I'm kind of new to this sort of rural living. I think mine is a standard mailbox, but if I walk down the road a half mile, there is one guy who has a mailbox that looks much bigger than the other ones around him. So that must be
It's
that
worth
rural
having it
mailbox. Yeah, that
because you
sounds
can
like
get much bigger packages delivered directly.
Well, I'm thinking when we move, my mailbox is going to be about 600 feet from the house. So Postal Service is not going to come up to the house and deliver mail. They're going to put it in the box at the bottom of the driveway. Well, if that's the case, I get lots of priority mail stuff. I got to have a bigger mailbox to take care of that stuff. So I hope they make a bigger size yet that you can, you know, a drawer you could pull out and drop stuff in.
Nathaniel, your local hardware store carries that larger size box.
Yes, that's where I get mine.
Yeah, we have a good Ace Hardware right down the road from us.
I've had to replace mine a few times because it gets hit by snowplow and the occasional baseball bat.
Yeah, same here.
The James Bond model that when they hit it with the baseball bat, it explodes.
We have several people on our street that encase their mailbox in bricks.
It's in bricks.
Yeah, they build a brick pillar and then the mailbox is inside the brick pillar.
Well, I bet they don't have too many baseball bats then.
Yeah, we've had a series of young people that like to use baseball bats on mailboxes.
I just put a steel post on either side of the mailbox, and when they hit it with a bat, they're going to get a shock.
So I used to live in a very rural place, and there was a guy who kept a truck would drive by and knock his mailbox off. So he ended up getting a road grader blade and putting it on each side of his post. And the next time the mailbox was still there, but a piece of the fellow's truck was on the ground.
Serves them right. Hey, when we first got the school bus for the Explorer Post, we parked at a Rally's hamburger place. And next door to the Rally's hamburger place was a little mini mall, and there was a liquor store and some other stores in there. Well, the liquor store was the only thing open at the night that we were in there. And we're sitting there eating a hamburger at the Rally's, and we hear this crash. And we look over, and this woman has parked at the liquor store. She got whatever she was getting. She backed out and backed into the bumper of the school bus.
Oh, no.
And she had like a Honda Civic or something, and her tail light was about even with the bumper of the bus. So we come running over, and she sees us, and she takes off because she thinks we're gonna, I don't know what we're gonna do. But we go over to the bus. The bumper isn't even scratched because it's like 1/4 inch thick steel U-shaped big thing like this. And there's this pile of plastic on the ground. The tail light lens and little bitty pieces of the fender, pieces of the bumper, all just laying in this pile on the ground in front of the bus. And so I chalk it up to school bus 1 Honda 0 because it must have cost her $1,000 to get her car fixed, I bet. After she really hit it pretty good and pushed the fender and all that in, but didn't even scratch the bus at all.
So, Scotty, do you have anything that we should talk over with Con that Nathaniel suggested we work together?
Not quite yet. I've got to get the FPGA pin out to the point where I can say, yes, it's going to compile.
Yeah.
And then from then on, we can go and work on the test code, which is what will be the fun part.
Yeah.
So exercising the hardware.
So, would either of you be able to, I'm planning on having a standing meeting with Kung each week. It's
Okay.
going to be on my schedule. It looks like I currently have it set for 11 a.m. Eastern on Wednesdays. Would either of you be able to come to that?
So 11, that would be right after the regular grape meeting, right?
No, I'm sorry, Wednesdays.
Wednesday.
11 a.m. Wednesdays.
I thought grape great meetings on Wednesday or Thursday?
Thursday.
Thursday.
Okay.
Yeah.
Yeah, I think that would work for me. I could do Wednesday. Let's see, that would be 11.
That'd be early in the morning for you.
I don't know, 8 o'clock, Nathaniel, that's pushing it.
I could make it later in the day.
Yeah, that would help, I think.
Okay.
So
usually Wednesday is my day to meet with my business partner and go to lunch. So I'm usually, maybe you should just leave it at that time, because once we get out going to lunch, and we don't talk to each other mostly during the rest of the week. Usually our lunches are at least 2 hours.
Okay.
So we'd have to make it considerably later in the evening, or in the afternoon, which probably wouldn't be as good for you.
Okay. Yeah, because I think the other times I was planning on meeting students that they would be 1 p.m. Eastern and 2 p.m. Eastern.
Because 1 p.m. Eastern will be 10 o'clock, which would that would work pretty good. How long do you think you're anticipating they're going to last?
I'm scheduling them for 50 minutes. So, I'm trying to not make these super long. And I don't know, how much guidance we need to give Kung, how long we need to meet with him. And I'm also asking him to attend this meeting on Monday nights.
Okay.
So I'm going to ask him to come to this as well.
I don't know, maybe this meeting would be the best venue, because once we get the hardware going, there's not going to be really a lot of discussion of that. It'll be mostly FPGA stuff, won't it?
So one thing I could do this week is I've been collecting relevant Intel documents on working with the Max 10 FPGAs and some of the tasks. Well, one is a little bit general, but the rest of them are the specific tasks that we're trying to do. So at least that gives you some reading and some videos to watch.
That sounds good.
We could go over maybe what we're trying to do.
I'll probably put them on the Tangerine website and then send a link to.
So how should I get Kung started this week?
Well, get Quartus installed, get where you can talk to, or at least get the development board attached, and where
did you get a DK2 development board, Nathaniel? You got one of those, right?
Yeah, I bought exactly what you told me to buy.
Okay. So the thing to do would be to get the sample projects up and running on that board. Go through the exercises on that board.
Most of them are blinking LEDs, right?
Yeah, I mean, that's the first one. But then, I mean, they use the same RAM that we use. So it would be illustrative to do that. And also one thing we can do is instantiate a softcore processor. And because he has C experience, right?
Which experience?
Experience with C?
I think so.
Programming?
Yeah, I think so.
Okay, so because that's the area that I'm going to need the most help in, is programming the softcore processor in the part.
Yeah.
Okay.
So to be able to instantiate a softcore processor and get it to blink the LEDs, that's the next, I think, one of the next labs.
And some of those documents I have describe that process.
Okay.
So I'll set up a page with the links to those, and then anybody that's just casually interested can look at them. But
do you think maybe we don't have to set up a standing meeting, but do you think you could meet us, say, this Wednesday at 11 a.m. Eastern, and then to get us started, and then from then on we'll just have him come to these meetings?
I think that'd be I can do that.
So Dave, do you think you could make a separate page for this project?
Yes. It'll be on that, like the other projects. It'll just be related to the FPGA.
Because I know I was supposed to send you my blinking LED program, and so far I haven't done it because It's on the list there, though, you know.
Yeah.
Get got on there, but
We'll get the radio built before you get the tubing.
I know, and then I'll get you the test code after the code's released, right?
Right.
That's great. I'll send you an invite for a meeting this Wednesday.
Okay. Good.
That sounds good. And then, yeah, as I said, I'll have Kung start coming to these meetings, and then he can check in regularly here. But if we at least get him started this Wednesday, I think that'll be really good.
Well, my first things are going to be just getting familiar with the board that you have.
Mhm.
And then we can kind of focus him down the road of things that we need to accomplish. We need to build.
Yeah.
Like the RAM, for instance.
Yeah.
So I think he just said that, I mean, he's got his mic off, but didn't he change his computer over to Windows? Is that going to be a problem, Scotty?
Yeah, it is.
So he needs a Linux machine?
Yes.
He just switched from Linux to Windows.
Yes.
I mean, you
Kung
can do all those labs, but you can't do the memory one because it doesn't work.
Well, that was Kong. Kong switched
Oh.
from but Kung, I don't know about
Okay.
Kung.
Kung. Okay.
I will make sure he has a Linux. I have a Linux machine that he can use. We're gonna have a desktop.
Oh, he's
here.
there with you and
He's there with me in
Scranton.
Yeah.
Okay.
Yeah. So let's see. I definitely have an extra desktop that he can use on this right now. I may have to look at buying another laptop for him.
How much memory does it have?
The desktop?
Yeah.
I think I have potentially like 60 gigs of RAM for the desktop.
60 or 16?
60.
Yeah, that's plenty.
Is 16 enough also?
Probably enough for what we're doing, but 8 probably is not enough.
Okay. Because if I were to buy him a laptop, I'd get him an Ubuntu 20.04 laptop with 16 gigs of RAM.
And like an i7,
yeah,
11th generation or something.
Yeah.
Yes.
That should probably work.
Yeah. So if I were to order, I just ordered one of those for one of my other students. So if I had to order another one, I'd probably order the same thing. I probably should have just bought two.
And it would be good too to have 2 monitors if you can do it.
Okay.
If you can plug them on, I mean, if you can plug them on the laptop typically, but it's good to have like at least a 27-inch monitor. I have 2 32-inch monitors and a 26.
Okay.
And I continually whine about the stupid low res 26-inch monitor, but because I got 2 32s, here and here, and then there's the poor little orphan over here. And the problem is when you try to move the cursor, if the cursor's at the top of the 32,
yeah,
try to move it over to the 26, it hits the edge and won't go.
Yeah,
because you got to go down and it's
yeah.
We can probably work something out to get him a better setup. So that'll be part of like meeting with him and trying to figure out what he needs.
Okay.
Yeah.
I know we got one of our guys is working on CVA9, the IQ2, and he's having trouble compiling with only 8 gig of RAM. So 16 gig is kind of like the minimum as far as I can see.
Okay.
Although this part's much smaller than the CVA9.
Yeah. Well, the 2 desktops I think we should be able to get like 60 gigs in them. So.
And they're like quad cores or better.
Yeah. Yes, they're quad cores.
I think it seems to perform a little bit better under Linux than it does under Windows for some reason. I think maybe the overhead's lower.
So we may have to get him some. We may have to get him some new additional monitors. We could do that. It's just a matter of how fast they come in.
Yeah, because if you have a display port on the computer, you can put 2 monitors on the 2 externals on that.
Yeah, yeah.
I know the problem I have with mine is I have a display port. I have a display port, an HDMI, and a VGA. And the VGA does not support greater than HD. So there's no point in getting a 32-inch monitor with QHD I can't use it on this machine along with the other two monitors.
Right.
So even though it would be nice, monitors are
Yeah.
like, I think they're like heroin, you know, once you get like a couple big monitors, it's like, I gotta have more.
When
monitors.
I was in grad school, I think I had like 3 regular monitors on my desk, and then I had my laptop sitting there. And then they had our lab, they decided to buy a TV, a 42 or 52 inch TV to put on the wall next to me. And that was going to be for displaying radar data. So I worked it out with one of these, I forget what the program was, but one of those programs where you could have your mouse drag from one machine to another. So I was able to control all like 5 monitors from my desk.
Yeah.
Oh, it was fun.
Yeah, when I had my office at the building, I had 6 monitors on my desk. But it was connected to 3 computers. So
yeah,
no more than 2 per. And then I bring my laptop in and I have to have an external monitor for that. So the joke was my desk was like this U-shaped thing and the back of the U was against the wall. But I had enough monitors that when anybody would come in to visit, if they sat down, I couldn't see them because they were behind all the monitors. It's like the great wall of monitors.
Yeah, you need that.
You couldn't just set up a webcam on the other side of the monitors?
And there he goes.
Yeah, there you go.
Yeah.
You make the assumption that I want to see on the other side of the monitors.
But then you would need another monitor.
That's right.
Yeah.
Hey, I remember when we first opened the office, it was in 1998. We got a Logitech USB cam. Remember the little ball cam that's set on the triangular base, and you could turn it around in any direction you want. Well, we had a part-time receptionist in the front, so we really had to, if somebody came in the front door, we had to be able to see who they were to see whether we needed to come out and throw them out or meet them or whatever we're going to do. And the latency was so bad. One of my associates, Steve, N6IA, he worked in the back. He could come in the front door, and if he ran to the back, he could see himself come in. The latency was that long.
Oh my gosh.
So here he is running up and down the hallway going like, what in the hell are you doing? It's like, oh, I'm just checking your camera out.
Nathaniel or Scotty, I'm gonna head out. So this week my baseball team is in the West Coast, so the game's just starting now.
Oh, what team are you watching?
Cardinals. They were just in Phoenix last week. So
okay.
Wow.
So anyway,
okay. Well,
I'm gonna say 73.
Thank you,
talk
Dave.
to you on Wednesday.
Talk to you on Wednesday.
Yeah.
Thank you very much.
So you're gonna send me an invite, right, Nathaniel?
I will, yes.
Okay.
I'll send it
still,
tonight.
I still haven't sent your magnetometer out, so you can beat me up for that, but I'll try to get it out tomorrow.
Okay,
so
thank you.
You can. I got it separated from the fold, but I got to get it packed in a box properly and all that. So
yeah. Well, as soon as you send it out, I'll find the other one. So
yeah.
Right.
I was thinking of sending you an empty box because it might work enough that you would find.
I don't think it works like that. I think you have to actually send one.
No, I think it is tied in with Murphy's Law, and they know what's in the box. So
yeah, they do. I mean, I looked. I see the drawer that's like right there.
Yeah.
When I went to, I thought I put the magnetometer right in that drawer, and I went. I don't know.
Well,
they do have a finite vapor pressure.
Have you looked at the top of the desk? Maybe it's stuck to the top. You know that.
Maybe I looked underneath. Rachel and I, we both spent like the better part of an afternoon looking everywhere we could think of.
Well, I have an ICOM 7300, and I lent it to a buddy of mine.
Yeah.
Now the 7300 has a different power cable than this. It has the same square 2/2, but the pins are flat pins. They're not round pins.
Oh.
So it looks similar, but it's completely different from any other older radio that you have, any other ICOM radio that you have.
Okay.
So I lent him the radio, and he says, well, I can't run this radio because my power cable doesn't fit.
Okay.
So he came back over, and I lent him the power cable. Now he brought the radio back, and I can't find the power cable anywhere.
Oh, no.
And it's a
Oh, boy.
special one, so I'm gonna have to buy another power cable because I lost it. I don't know where it is. It's not connected
Yeah.
to the power supply. It's not sitting with the I have the radio sitting over here where he returned it.
Yeah.
And it would have been with the radio, but
Yeah.
so it's the same
Scotty, I have a question about the magnetometers. When you sent me a set of the new boards,
Mhm.
it had a magnetometer in it, correct?
Yep.
Yeah.
Got a card on one of the
Because,
boards.
yeah, talking about vapor pressure, I had bought two units myself, and then the one that you sent me, and I can only find two of them now. One of them's
Right.
missing.
You're talking about the little daughter card from P&I, right?
Yes, exactly. The
Yeah.
breakout board,
Yeah.
which I had bought two of my own, and I can only find one of them and the one that
And
you
then-
sent me.
Oh, so okay, but you did find the one
I-
that I sent you. just
Yeah,
not the other
the one that you sent me, I believe, is the one that's still out on the board that's being used right now.
Okay.
But I had bought two, and I can only find one of them. And the one that I found is one that had gotten damaged. So
Okay, so it's
down to
not-
one working one.
so do you need another one? I mean,
I'll find it.
you get stuck. I got spare one here, so
Yeah, that's okay. Don't worry about it.
need to. It's
Of
just
course,
such
I
a-
suppose I wonder if we're able to buy any more of them. They're probably having the same chip problem everybody else is.
yeah, I don't know who makes their chip for them.
Yeah,
Well, all of the pairs
they
that I have-
certainly aren't the foundry. They're having it made somewhere.
all the pairs of boards that I have those chips with them. So I mean, they have the boards with them. So
Right.
Rachel used to make chips when she worked at SRI in New Jersey. And I keep trying to tell her that we should
start your own fab line. Yeah.
Yeah, I know. I keep
That's
saying
a good point. I think
we need to get some sputtering machines or something and then turn our barn into a fab.
How much power
Yeah.
can you get routed to your farm there?
The barn? I don't know. Well, we've got 200 amps going to our house. We only
No,
have like
that's not enough. You need like 1,000 amps. Then you
Yeah,
can
be careful. They'll think you're growing pot.
Is pot legal in Pennsylvania
uh
for medicinal purposes? It is here. in
yeah,
Arizona.
for medicinal purposes, I guess.
But you probably
Yeah,
gotta-
for medicinal purposes, I see these stores all over the place. So I mean, I
You
guess
probably have to have a license to grow it.
Yeah. I don't do that, so I don't know. I haven't been paying attention. But
Yeah, well, yeah, Dartmouth should go into the business too. I know that their school's got fab equipment.
Instead of saying you grow pot or medicinal marijuana, you can say, let's just say I've got a federal license, and beyond that, I can't talk about it. and just create that air of mystery of what's really going on outside there, and then just count the number of hours till you show up on social media with some sort of conspiracy theory. Conspiracy, this is happening, blah, 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 blah. Fill in the blank of your favorite conspiracy.
60 Minutes news team shows up at your front door, right?
Yeah.
Right.
Not a good thing.
Hackaday had a nice post today about this guy Yuran Legar, how he built his own physical vapor deposition apparatus. He goes through a whole video of it. So we were watching that tonight.
How about the guy that builds his own vacuum tubes?
That's pretty cool too.
That's what I want to do. I was
Yeah,
talking to N6IA. We were having dinner the other night. We were talking about projects from the past that we want to do. And I wish John was here, John McGibbon, because we built those 4-letter word generators with the neon 4-inch tall tubes.
Mhm.
And Steve is the other one. He and I both built those. We designed them and built them from scratch. And we were talking about in the old days, like when I was in high school, if you wanted to buy a digital clock kit, that was like the better part of $100 bill to buy all the parts to build just a clock. And so now I told him, what I want to do is I want to build a digital clock out of NAND gates. I want to take a bucket of 7400s and I want to build a digital clock just out of NAND gates. And he says,
Not
well,
that hard.
I want to build one out of 2 and 2222s.
Okay.
He says, I'll build an inverter and then I can wire them together and make gates. And then I can wire those together to make counters. And then I said, yeah, you should make it modular like the Tangerine. And you could build a little board with a gate on it. And that could plug into a bigger board that might become a counter. And then you could plug that onto a bigger motherboard that would have like a spot for each digit. And then you have to have like a diode matrix for the 7-segment decoder, because you can't use a 7442 or whatever it is. You have to use transistors or diodes.
Have any of you seen the project called Monster 6502?
No.
They built a discrete version of the 6502. You can do a search for it.
How many transistors did it take?
Oh, I don't remember.
Well, remember
There are
the
pictures
Apollo
of it on the web.
The Apollo computer was built all out of NOR gates. They used one RTL chip. There was a bunch of NOR gates, and it was all built out of that.
Wow,
that's all you need.
My old boss built a CPU out of TTL.
Yeah. Well, hey, I was designing TTL processors when I was at New England Digital. Our processor was TTL. Very nice reduced instruction set machine.
Chat window go.
Very power dissipative.
Yeah, but it worked very well. And as I like to say, it was comparable to like a 68,000 for processing speed. And it was 2 boards of TTL, small boards. I built my first electronic clock out of TTL from scratch. So the largest was the decoder.
But you probably use 7490
7-segment decoders.
You use BCD decoders or something like that, right? You didn't actually build the counters out of gates.
Yeah, well, I used 7490 counters, and I used 7447 7-segment decoders. But it was all TTL, and it was MSI Max. And yeah, the gate, you could actually take all of those chips and from the schematics on their data sheets, very easily built it out of NAND gates, as you say.
Yeah.
Or transistors. You know, I date back to the computers that were using transistor logic.
I was just looking at the specs on this Monster 6502, and they're saying because it's discrete, the maximum clock rate is about 50 kilohertz.
Dear.
Jeez. Kilohertz?
Kilohertz, 50 kilohertz. Well, it's the board's like 2 feet by 2 feet. I mean,
well, you remember when you built boards and they were 1 to 2 megahertz, and that was fast.
Yeah, and the parts didn't keep up.
Then 20 megahertz became fast, and then 50 megahertz became fast, and then 100 megahertz became fast.
Mm-hmm.
And now with proper precautions, we can run 122.88 megahertz all around the board if we use the right connectors, but use the right layout techniques. But nobody would even think of that back, in like 1975.
Yeah, our TTL computer, by the way, is used. The largest scale that was in that was the 181 ALUs.
Okay.
And it used discrete registers and
so you use like
stuff for the sequencer and all that.
Bit slice.
Like 373s or 574s for registers, 8-bit wide registers. Yeah.
Yep.
And now
it was a 16-bit reduced instruction set machine, had about 20 nanosecond cycle time, maybe.
They have
64-bit
versions of those registers now.
Yeah.
It's just in huge packages, but
right.
God.
You have to be able to solder fine pitch pins, but
yeah, I'm just trying to figure out who would actually use something like that rather than use just a CAN processor and an FPGA or a CPLD even. Anyway, we had a need in see what year was this? Probably would be 1982 or maybe 83. And we needed a 16-bit tri-stateable counter. Now, PALs were out, but there were no PALs bigger than, I think, 10 output bits, maybe. We couldn't, or the 16.
22 V10 level.
Yeah, and they didn't have tri-state on all the outputs. So I couldn't get it on the particular one I want. I couldn't get 16 bits of tri-stated output. Well, we came up with this stupid harebrained idea. We used a 6800 as a 16-bit counter. It has a tri-state control on for the bus. You wire the data bus to a no-op, and then the address output is the instruction counter, and it counts up, and you pull tri-state control, and it goes high Z, and it's $1.50. The only drawback is it takes 2 clocks 90 degrees out of phase at 0.9 VCC. I mean, it's a very picky on the clock that it wants. And it's also in a 40-pin dip. So it's a big honker, not like the little parts we wanted. So we ended up not doing it, but I came close to just putting that on the board as a 16-bit tri-state counter. It was the cheapest, lowest power solution that I could come up with. I'd have to use 2 PALs, 222 V10s or something like that to do the same function. So
yeah, that was before they started doing the quad pack PLCs.
Yeah. Then the 82S105 came out. I don't know if you remember that. That was it was a 16-bit, 20-bit sequencer. And it was a precursor to all the well, it was a CPLD, but it was more than just a PAL array. And because it had buried registers that fed back, and then it had registers that fed out to pins. So that part was something else, because I remember using that before Data IO actually had the compiler, or I guess it was Signetics was the company that made it. And they had no compiler for it. PALASM did not support it yet because it was a brand new part. And so what we would do is we'd go into the data book, we'd open the data book up, we'd put it on the Xerox machine, and we'd blow it up like 4 times. So we get like this 4x or 8x view of the matrix of where the fuses were. And then you'd write your equations, then change them to Carnot maps, and then you would mark X's on the diagram where you wanted fuses blown. Then you take those X's and convert them to addresses and come up with the hex listing. And then you type the hex listing into the Data IO and program the part. And it was fuse link. So one-time programmable, that's it. So you make a mistake, got to start over. Want to make a change, got to start over. And it's amazing how when you go in and you change one term in one equation, how much work you have to do to go through to get down to the hex file that you get to load in. Oh, but I was at Motorola then, and we were the first ones that used that part because no one else could program it. But we figured out a way to do it. Just painful as all get out, but it worked.
I don't remember who it was, whether it was Altair or Xilinx that was coming around, but I remember when they were coming, selling the very first FPGA.
Would be Xilinx because they were in business first.
Yeah,
that would be a 2064 probably.
Right, but until then, you had electrically erasable ones, but those were the first RAM-based.
RAM-based was, and they were 64. It was 8x8, 64 CLBs. That's what you got.
Right.
It seemed to me they had like a 2032 when it was smaller too. They had two sizes, maybe a 2016 even, but that would be too small.
Right. The other thing I was going to talk about early days of was hard drives, because we're getting 10 terabytes for $200 now. I remember when it cost you $3,000 for 5 megabytes, and we would fill that up in seconds doing 16-bit audio recordings.
Yeah. So how much audio would it take to fill up your 10 terabyte drive, Nathaniel?
How much audio?
That could go for probably decades.
Don't they have on your box there how many MP3 songs will fit on that?
Oh my gosh.
Yeah, because a CD, if you round up 50 kilohertz sampling, 16-bit, 2 channels is 200 kilobytes per second.
I mean, I was
okay.
And then,
Because I always thought it was about a
remember how
minute
s-
per megabyte, but that's an MP3 file, not like a WAV file or a sampled file, a CD file.
Yeah,
let's see,
it doesn't try to make any
seconds.
claims like that on this box. I was impressed though how fast. I don't think I've ever burned through a hard disk that fast.
In one day, that is pretty impressive.
Yeah, it wasn't even
Yeah,
a full day.
basically CD rate is 12 or 10 megabytes per second.
10 meg per
Yeah, roughly speaking, 10 megabytes per second is,
second or per minute.
oh, per minute rather.
Yeah.
Sorry, 10
Yeah,
megabytes per minute.
MP3 is roughly
That's
10
at,
times.
that would be, you know, that 44.1
Okay.
16-bit 2-channel.
So that would be like a dot wave file. Would be
Right,
about
exactly.
10 meg per minute. And then a dot MP3 is roughly 1 megabyte per minute.
Yeah, that tells you how much compression in there and why I hate listening to MP3s.
Yeah, so my buddy is collecting bootleg songs off of the internet, and I don't even know where he gets all the stuff, but he's collecting them all at 256K sample rate.
Mm-hmm.
And he says, well, I'm thinking about redoing my whole collection, trying to get them at 384K VBR, you know, variable bit rate.
Right.
And I said, you're 60 years old. I defy you to tell the difference between a 256 and a 384. You can't tell the difference. And so we went home and he tried it. And he says, okay, never mind. I'm not going to do it. He can't tell the difference.
Oh boy.
I'll have to try. I used to be able to.
We had, as a good example of that is we had a power supply that we built. We had built for us at Motorola, and it went in the Linux box that we were making. And we could actually, by running an FSCK program under Linux, we could actually blow up the power supply, because the disk accesses would beat with the power supply frequency. And it just, the way the guy built the power supply, it was from National Power. So we actually went over to San Diego to talk with the engineer who built the power supply and to figure out why. I mean, we could literally blow transistors off the board of the power supply and destroy it. So we go over there and he's got our power supply all set up, and he's got this giant machine that will do all kind of variable loads, and he can change the frequency of the load, and he can change the, you know, he can go from 10 to 90% load, and he can do that at 1 kilohertz, you know, and so he can really exercise the power supply seriously. So he turns the load on. We tell him, well, okay, our FSCK does this. This is the load frequency that you're going to get. So he dials that into his machine, and he turns the thing on. And me and the other guy, and now remember, this was back when I was probably in my 30s, so I could hear reasonably well. This guy was a 60-year-old guy like I am today. So he turns the thing on, and you can hear the supply, and it goes, and you go like, turn it off, and then the transistors blow off of the power supply. And the thing was, he was saturating the core because he wasn't keeping the active high and active low times on the PWM the same, the area under the curve the same. So he would shift it like this, so you get more positive and less negative.
Yeah.
It would shift the, it would
He was
bias
walking the core out of the,
right, and then it would hit the limit, and you could hear it actually modulate the windings on the core as it saturated, and he could not hear that. And so he could not, he didn't understand that he wanted to know why we could tell when the thing was going to explode, because he could not hear that frequency.
Mm-hmm.
And I mean, maybe it was 15, 20 kilohertz, but it was enough that we could hear it. And so he fixed it. He figured out what was wrong, how he was not keeping the zero crossing in the, I mean, the high and the low, the same area. But it was just, I thought it was amazing that we could hear it and he could not. And now it's probably just the reverse, is that, so I shouldn't be designing power supplies. But this is 300 watt supply, maybe bigger. It mounted on the side of the case, so it was a huge big.
Nowadays, I dare you to hear the 1 megahertz switching frequency.
Yeah. I can hear the transistors exploding though. That's pretty easy. Yeah, 1 megahertz be kind of hard. Oh well. Just the
Yeah.
fun we had in the old days, you know.
Yeah, so just figuring out that rate, as I say, we started doing audio sampling on 5 megabyte drives. So you fill that stereo in 30 seconds.
So, so what did you do? I mean, that's kind of worthless then.
It was the very beginning of it, and it was you just got short snippets of instrument sounds. We were doing a synthesizer.
Okay.
And
okay.
That was the very beginning. Then of course we got them larger and larger, but even an 80 megabyte drive, you didn't have a whole lot of recording time.
Yeah. As I remember at Motorola, we were in our department, we were evaluating hard drives, and we had Maxtor, I want to say 54 megabyte drives. They were full height, 5 1/4. So they were big. And then we get a bunch of drives in and we test them, and then they didn't want the drives anymore because they either decided they were going to use them in production or not. And so we got to take them home. But these were MFM drives. So you had to buy a special controller. So, and Conan, I don't even remember Conan for
Rings a
PC.
bell. But
Anyway, they were in Tempe. And so we called them up and we conned them into selling us direct some MFM controllers to go with our Maxtor drives that we had purloined from Motorola because they were going to put them in the dumpster. They didn't care. They didn't want them anymore. And so we had 54 meg of storage on an XT. Woo! Now, I didn't do any audio, so 54 meg was a lot. And we didn't have, megapixel cameras. So there was no, I mean, what would you put on your drive? Microsoft Word documents, pictures at 640 by 480, that were relatively small. So.
Yeah, but so we were driving, we were always looking for the largest hard drive available, and it was always $3,000. And of course, this is $1980.
Yeah.
That's expensive.
And but yeah, we ended up ultimately it was world's foremost hard disk recorder for a while.
Well, so what brand of drives did you use?
I forget. Well, Maxtor and Seagate, I know we were talking to, and whoever was building them at the time.
Yeah.
But of course, this is the instrument that became Michael Jackson's whole performance.
Oh, really?
Yeah. His concerts were in the synclavier. He had 3 of them. One was in the studio, one was for the road for the concert, and the third was spare parts for the other 2. These were $500,000 units.
Wow. And what company were you working for?
New England Digital. It was an instrument called the synclavier. And they're still used. There's still a lot of users out there. And this is 1980s, 90s technology. And still does things that other things don't. But Pro Tools ate our lunch. They did a whole lot of what we were doing for a lot less money. And the company management didn't bring the costs down. We were trying to integrate things to bring costs down. They didn't, and it was too late. So it went belly up in 1992. And there has been continuing development since then, but that's when it really stopped. But as I say, the technology was very unique. We started in '76 and had the first FM synthesizer out there, first digital synthesizer. Before Yamaha,
you started
before anybody else.
Before there was a PC.
Yes. It was originally music synthesizer audio system built running off of a Nova computer. And then our hardware founder realized he could design a 2-board reduced instruction set machine that I was just talking about, stick it in the interface bin, and it was faster than the Nova.
Cheaper too, probably.
Yeah, it does very well. And I actually redesigned that several times to bring it up to current technology, using from the original TTL to F logic and AS and stuff.
Do you ever convert it to CMOS?
We didn't. CMOS wasn't that big
Back
at
then
the
it was a
time that
little
we
slow.
stopped development on it.
Yeah, CMOS is not very well developed back that early.
Right.
I remember
CMOS was still slow.
My professor at ASU hated CMOS, and he had
Yeah, though now that I think about it, it was coming in because the 16 V8s were around, the PALs that were CMOS.
Well, this was before that, so this was like 4000 series.
Yeah,
So
no, the
like
4000 series was way too slow.
like a NAND gate. that takes
HC
100
4000 you could use. But
the NAND gate at 100 nanoseconds or something. I mean, it was
right,
really.
right. Of
Anyway,
course, the nice stuff about the 4000 series is you could put very high voltage on it. And
so mine is 18 volts.
yeah. So
Well, I know that we had a mini computer at ASU, and the professor commissioned a student to build a core memory interface so we could add more core memory to this mini computer.
Mhm.
And he used a CMOS for, I want to say, a 4055. Maybe it was a 14555. Anyway, it was a 104 dual 104 decoder, like a 74138. Anyway, he put this in line with the addressing cycle because you had to pick between the 4 banks of
right.
And it's the time delay from input to output was 1000 nanoseconds, a microsecond. It took this decoder to select the bank. Well, I think the whole cycle time of the core memory is only like 1.6 microseconds. So it slowed the machine down. And so this professor was just beside himself, it's like, oh, well, the CMOS stuff is, oh, that's crap. It doesn't, it's too slow. And he just had nothing good to say about CMOS. So I think the guy picked the wrong part. I mean,
right.
You know, you should have used the TTL part. Even if you use the TTL part for just that piece and use the CMOS part where a CMOS part was usable, but he just picked the wrong part. But
yeah.
So I always felt it was the professor's fault anyway for not giving his student more guidance and then complaining about what the result was that he got. But then this is the professor that the first day of class, first student that asked a question. I'm not kidding you. I'm sitting in the back, and I'm like a teaching assistant to another professor in the same department. Okay, so I'm kind of like I'm a worker there. I'm not a completely detached observer like a regular student. So student asks this question, and the professor says, "Well, that's a really dumb question." There were no more questions the rest of the semester from anyone because he just raked the guy for a perfectly good question, but he just raked the guy, and he did it on purpose, knowing that this would just shut down all questions in the future and it would make it easier for him. And then he wouldn't have to answer questions. Bad. I didn't like that at all. My estimation of him went down quite a few notches that one day.
Yeah, there is no dumb question.
No, I mean, the guy wouldn't have asked it if he had understood. So why? Yeah. And the thing was, I bet if I had asked the same question, he would have answered it because he knew who I was. But them students, they're nothing, you know, and it really kind of a bad attitude, I think. Because it depends really on who asked the question. So fortunately, I worked for the other professor in the department. He was exact opposite. If you ask a really dumb question, he would still answer you. So he is a much better professor. I liked him a lot better, which is kind of why he was my advisor and not this cranky.
Yeah. The fact is, if you're asking the question, you want to know.
Yeah.
That's right.
And I think at ASU anyway, in those years, in the master's program, the postgraduate program, the people that you had weren't, I mean, they wanted to be there, right? Because they're paying money for this education and they wanted to be there, as opposed to some of the undergraduates are kind of like, oh yeah, well, you know, I got to be here. I got to, this is a required course. I got to take it, blah, blah, blah. But no, these guys all were interested. So to shut your guy down like that was really uncalled for, I thought. I mean, who knows? Maybe he made the guy quit the career entirely and switched professions just with one obnoxious comment like that.
That happens.
Yeah.
Hopefully none of my teachers do that.
No one ever did, fortunately?
No, not for me anyway. But I don't know about grad school, but no, I had really good teachers all throughout my college career.
Yeah. And see, that was the thing, is that this guy was a good teacher, I thought. He knew his stuff. He knew how to present it. He knew how to you could understand his lectures, but he just didn't like answering questions. So he had his method of turning them off.
Yeah, that's the thing. Well, there's a professor that I had that wasn't particularly helpful with my issues or my questions, but I just kind of did the best I could. You know, there's always that one, but
yeah,
overall, I was really lucky.
Yeah, I feel lucky too that I got in as a TA, and I got to see more of an inside view of that, because that would have really turned me off if I had just been in a regular class and the professor had done that. You know, take all the fun out of it. You know, hey, you're supposed to be here to maybe have a little fun too. Not good.
Well, I might be able to do a TA type of program and get part or most of my tuition paid for while still working full time. I might be able to do that. I need to hash out those details, but the advisor said it was possible.
So you'd be a teaching assistant then?
Yeah. Yeah, the only drawback is that I would have to be enrolled in a minimum of 9 credits.
Ooh. And work full time?
Yeah, that's kind of pushing it. 6 is even pushing it, but
yeah.
If I do less than 6, it's going to take me forever. So, but I don't know. I don't know. We'll see. It is nice not to have that huge college debt bill waiting for you at the end.
So do you have a limit on graduate programs for how long you can work on them before you get a degree, the time limit? Because at ASU, I think you have 6 years to complete a master's degree. Otherwise, you've got to petition the Board of Regents or something to get a waiver. And they said, my advisor said, you aren't getting a waiver. You got a really good reason to get a waiver. And
as far as I know, from the school that I chose, Wilkes University, well, they were the only one in my area that has an MSEE program. Out of the 5 or 6 colleges in my area, that's the only one. The only limit that I know of is the 6-year limit, or the limit that the Department of Education puts on you for grad plus loans, that you need, that you could only take out as much money is required to complete the program.
But that's a loan restriction, not a university restriction, right?
Right. Yeah. As far as I know, I don't believe there's a restriction at Wilkes, but it's a fairly different program. I don't even think there's any graduate entrance exams that I have to take, or at least they did not mention that.
Yeah, I didn't have to take anything for the master's program, but there is definitely one for the doctorate program at ASU.
Oh, okay.
So yeah, master's program. I mean, when I applied, I applied for admission and I was denied based upon my less than stellar undergraduate record. And so I came out anyway and I enrolled in classes.
Yeah.
And I proved that I could do it, but you know, you get good grades in the classes you enroll in, but you can only count 10 credit hours toward a master's degree before you are accepted in an approved program.
Oh.
So it was 30 hours to get the master's degree, but only 10 hours of it could count as like a freelance, I'm going to come here and take a course. Otherwise, you have to apply for admission, be admitted in the graduate program, get yourself an advisor, and get your program of study approved by the department with the help of your advisor. And so you could take all the courses you want, but only 10 hours are going to count towards your graduate degree. So you don't want to waste a bunch of time. So that was, but I had no choice because they didn't admit me. So I applied and they rejected me. So I had to take the courses, get A's in them, and then reapply and have them accept me.
Oh, wow. Okay.
But I was always a chance if I didn't get A's, or if they could have rejected me too. They didn't have to accept me. But I mean, if you take 3 courses in their graduate level curriculum and you get A's in all of them, and then you reapply, it'd be kind of dumb for them to turn me down. I mean,
that's true. Yeah.
Shows I can do the work, so why not admit me? And I mean, I had a 2.01 average undergraduate. I mean, I graduated by that much. I had a 3.9 average in graduate school.
Wow.
So it was a completely different environment, different type of courses. It's something that I was actually interested in, like actually real hardware and real number systems and real computers instead of at RPI. The only computer course that I could take was a Fortran course.
Wow.
That was it. So I really wasn't what I was interested in. And
well, this program actually has a lot of different topics. So Wilkes allows you to branch out in one of 3 areas. You could do communications, power transmission, or semiconductors. That's kind of what they offer, but I'm kind of torn between semiconductors and communications. They've got some, they have a microstrip class. They have an antenna course.
by semiconductors, you mean like fabrication and device physics, or?
Yeah.
Okay.
Yeah, they have a lot of fabrication tools from where I used to work, actually. A lot of the older tools that the place that I used to work at on Semi, when they got rid of them, they donated them to Wilkes. So there's a lot of options there if I did want to go into semiconductors, but I was just mainly going to focus on the VLF stuff and take the courses that I have to. And I was excited that I could transfer. You could transfer a minimum of, or a maximum of 6 credits. So I figured I would transfer control systems and DSP since I already took those in undergrad. So I sent them the information and hopefully I could get them transferred. That way I don't have to pay for them. So, but yeah, well, and they for whatever reason, they accepted me just like immediately. I don't know why. But I guess in this area, they need bodies to fill that program. And that's probably why that they accepted me. It wasn't all that, it wasn't all that competitive like it was for you.
Well, did you have, do you have to take any tests, or you just use your undergraduate record?
No, I didn't have to take any tests at all. I just gave them my transcripts. Both from my
if you had a 2.01 average, they probably would not have accepted you so readily.
Well, I had a 3.7 average from community college, and I had a 3.2 average from Scranton. and which is pretty dismal. But for
Sounds
someone
pretty good
working
to me.
full time, well, yeah, if you're working full time and trying to do undergrad courses, I guess it's not too bad. But they like my thesis or project idea, and I told them about ham sci and everything that I'm involved here, and they really liked it, and they'd like to get involved with it too. So I just got to hope that those courses transfer, and I'll register for classes. You know, what the hell?
All right. In what, a couple of years? Well, probably more than a couple of years. Probably what, 3 years maybe? You'll get your
Yeah.
24
Yeah.
more credits. So need 6 semesters, 4. Well, that's 1 to 2 courses per semester, right? For 6 semesters.
Two courses per semester. That's what I'm going to try to do.
So then you get 6 credit hours per. So that's you do it in 4 semesters then, if you have the right courses.
Yeah. Yeah. So I figured I'd be done in probably around 3 years. And then I'll be done for good. I don't think I'll go for PhD, but
I just want a PhD so people have to call me doctor. I know
I don't know. That's
the guy that I worked with. He's 80 years old now, and he lives in Austin. And he just completed his PhD in communications theory.
Wow.
No, that may not be what he's taken. Anyway, he just got a doctorate. And I go, Lorenzo, what are you doing? You're 80 years old. What are you fooling around with getting doctorate degrees for? He says, well, I'm going for my second one now. And I don't know what he's going to get it in, but he just likes going to school and he likes the environment. So this is his retirement hobby, taking courses.
Well, yeah, I mean, I honestly really liked going to school. I mean, people think I'm crazy, but I really enjoyed it. I learned a lot of stuff, and you keep your mind fresh and active, and it's not a bad experience, or at least I don't think so. But
you know, I used to think
look how many years I've been going to school.
Yeah.
Right.
I used to think it wasn't important until I got out and spent time in industry, and then I come back to, especially when SDR technology hit, and all of a sudden all this math that I really didn't like when I was in graduate school, and I avoided it. Now it's necessary. So it's like I got to understand it now. I can't just say, oh yeah, sure. No, you got to understand what's going on because you have to actually use it. And it's,
yeah.
And that, to me, that's what was the thing that I didn't like was professors that would get up there and bloviate on about all kind of esoteric stuff that I could never really find a connection into the real world. I mean, okay, so these equations are great, but what are they? What do I use them for? What can I build with those? I mean, show me that, and they never did. So I kind of got disillusioned with that. And then when I got into ASU, it was all about microprocessors and digital logic. And I mean, you could build stuff and you could make things that did something. and it was cool. And it was sponsored by Motorola. So when you were done, you could walk out into the Motorola, what do they call it? Had a program for graduates. And they provided hardware to the labs, and they provided a curriculum for the professors to teach, so that when you got out, they had students that had the background that they wanted to pull them in to work at Motorola.
Wow.
So it was great for Motorola. It was great for ASU. It was great for the students because we got to work on state-of-the-art hardware that, you know, I bet a lot of other schools didn't have because Motorola gave it to them. They said, well, hey, you know, if we give them a whole bunch of 1600s, then their next graduating class 2 years from now, their graduate class, they'll all be familiar with our parts. So
wow.
And so the one job I got right out of ASU was working for at a place that my advisor worked. And it was using 6809s. And I was using the software that he developed for the 6809. So on my first day, I'm in the lab and I'm doing the things that all the regular guys are doing. And it's my first day at the job. So the people who hired me were just ecstatic because here now they could hire a guy that's basically experienced from day one.
That's true, yeah.
Because the guy that works here is a professor and he taught him the stuff that he knows and he uses the same stuff at work. So it's cool.
Yeah. Well,
Scotty, I got a short little anecdote. You're talking about learning the math. This goes back a few years, and I remember it like it was yesterday because it was such a weird news story. There was a local ice arena in town that was notorious for having terrible acoustics, and that's where they did all the concerts because it was the only one around. And this news story was talking about this professor from the local college that was doing a study, but the film they rolled was of a gentleman sitting right in the middle of the ice arena with a shotgun, and he was shooting blanks. And it's like, what in the world they are doing? Now, roll into the 1990s, and I finally realized they're doing impulse response. They were probably recording that, taking it back, and somebody probably key punched the thing.
So they
this was the 1970s.
So they mic'd it up and then shot the gun off and recorded it, right?
Right. That's what they were doing on site. But, on the back end, they probably took that somewhere, digitized it, used the math on signal processing because they've known that math for years. And it wasn't until the 1990s, 20 years later, that I figured out what they were doing.
Yeah. Well, I worked with a guy that worked for the companies that build. So are you familiar with the audio shootouts? I don't think they do these anymore, but they used to have where they'd take a car, they'd play speakers, or I guess the user would play speakers in it, but they'd play a particular tape or recording, and then they would measure the sound pressure inside the vehicle. And the guy who had the most sound pressure at the pressure points would win, right? So these guys actually hired a DSP guy to build phasing units that would phase the audio such that at where the microphones would be the high points, so that he could get a better score on the test.
Convergence of the waves.
Yeah, and I'm going like, are you kidding? So this guy's making $100 an hour this is a long time ago, $100 an hour as a consultant doing DSP work. And I go, well, what's your product? And he says, oh, well, amplifiers for shootouts. And I'm going like, that's really worthless. It's like, nobody can even sit in the car when they turn these amps on. They're so loud. A friend of mine actually broke the rear window out of his minivan with a woofer that he had mounted back there. I mean, don't you worry about what that does to your brain when it hits the sound waves?
Well, as a post epilogue to that story, they never fixed the acoustics, and they've actually now torn the building down. It was just awful.
So all that research never really produced anything that was.
Well, it may have come up and says we need to do all this, and it probably would have cost more to retrofit the building than tear it down. So they decided to do nothing.
Yeah,
like the Hara Arena.
Like the Hara Arena.
It was kind of that era. Put it this way. It was a post-World War II ice arena. It was just a big box, so vertical walls everywhere.
With
that sort of thing happened at Dartmouth when they built a new rink and wanted to set it up so that they could have concerts in there. And they went through and had a proper design done for putting up acoustic curtains and such to damp the resonances. But when they finally built it, they nixed that part of it, and it was horrendous.
So it was just an echo chamber?
It was just an echo chamber.
Yeah.
But they want, for hockey, you wanted it to echo. And they could have had maybe roll up curtains or such, but they never put them in. Though I will say there were bands who knew how to work that. And I think the one I was most impressed by was Marshall Tucker. And they had a sound guy that had a third octave equalizer, and he knew how to use it. and it actually sounded good in this echo chamber. It's quite remarkable.
Cancel their own echo.
Yeah.
He brought his own speakers though, right? I mean,
Oh
instead of-
yeah. It was all their own sound equipment. He knew how to work the room.
Wow. Yeah, because some places are just better than others, like the concert hall in Troy, New York, where RPI is. It's one, and I don't know if it's still even standing now, but it was one of the best sounding concert halls in the entire country. And they really, at the time they built all these, they didn't really know why. They didn't have the engineering to design it so that it sounded good. Or maybe they designed it so it sounded as good as they thought it would be. And then some of them didn't measure up and some of them exceeded expectations. But it comes down to, I mean, even the kind of foam they have in the seats. All that stuff has to be taken into account to determine what the acoustic sound is going to be like in the hall. Anyway, this is one of the best ones that there was. And I remember they were worried because they had to remodel it, right? Well, they had to recover the seats. And they're afraid they're going to wreck the sound by changing recovering all the seats in the auditorium. So
but that's interesting because once you put the people in the seats, it's the people doing the absorbing.
You think so, right? But I don't know.
There's been studies that say the changing fashion of the populace has actually affected the acoustics because the clothing is different.
Oh, that could be.
Made out of synthetics instead of cotton, or fluffy instead of
or wool, and we got polyester and whatever. So
I knew Dave Griesinger, who worked for Lexicon, and of course he's best known for the design of the Lexicon reverberation units, but his other talent was designing the acoustics for auditoriums, various spaces.
So,
and,
like you mean like the curtains that they would hang, or the
and
pillars?
some of them from design, from building them so that they would sound good. And the design of the walls, design of the acoustic curtains and such and whatnot. It's quite a talent.
Well, probably an art more than a science too, isn't it?
Well, I would say, knowing him, there was a lot of science to it. It just may not have been able to be written down. But there are people who know what they're doing and know how to make it sound right. It has a lot to do with the reverberation time in it and frequency response of the reverberation.
I said shotgun on the floor.
Yep. No, a shotgun is exactly, that's what something like that is exactly what you use to get the impulse response. I like sounding a room just by doing a click, a tongue click.
If you use live ammo, then you can remodel the room while you're measuring.
Yeah, we need a hole over there.
Yeah.
Ablative changes.
Oh, no, it sounds much better.
Nathaniel mentioned that in his DSP class that I was in, that I'm trying to get transferred, that there was a situation where he used a shotgun to get an impulse response.
It's pretty clever.
Yeah.
Certainly, shotgun seems like a pretty large thing, and it's got a low frequency response that probably is not ideal. But starting pistol.
A 22 blank would be just effective, right?
The starting pistol works well.
Wideband noise.
Yep.
The poor guy that was on a set that they had a pistol that was loaded with blanks, and he's fooling around and he puts it against his head and pulls the trigger, and the wad kills him. He ended up getting killed by fooling around with this pistol supposed to load with blanks, but it's not really completely blank. Okay, there's a wad of paper in there, and that penetrated his skull because he put it to his temple, and
right.
Well, we got way far off the subject of. So, Nathaniel, when do you have your? You don't have a present. You have a presentation coming up here at the end of June. Is that your next one?
Yeah. So the week of June 20 through 25th.
I forgot to ask Dev about the one the weekend before that, whether they still want a recorded session or not.
Oh yeah, I don't know.
I'm wondering if.
I think I told them it was too much for me to do this year.
Yeah, but Devin, I think it said that they asked me if I would do something, and I thought, well, couldn't I just give them the recording from the last weekend that I did? Because it came in at exactly 30 minutes.
Mm-hmm.
And it was pretty much, I stripped out all the super tech stuff and just covered the 4 boards that we're going to have. And I had pictures of the layout. So it was like, yeah, this is real because we got a layout of this.
Mm-hmm.
And just kind of stripped out all of the why we were doing it. And so a lot of the personal space weather station wherewithal was removed because it was focusing really on the Tangerine.
Right.
And not on why we were doing it. Although I had use cases in there, so I stole one of your slides, and the one that you've probably seen in every presentation I've done. And by the way, I left the NSF grant numbers in there.
Oh, good.
So if you're still looking for presentations that have been done with those grants, I got 2 more for you.
Wonderful. I will. I have to file an annual report every year. So at right around Christmas time, I'll send out another email asking for everyone's
I did one. I'm trying to think what was the last one that I did. This is Memorial Day. It was Hamcation.
Hmm.
And then, well, a Hamsci, of course, it was in that the presentation for Hamsci.
Yeah.
And I don't think there's been anything since then. I do have a local one at the local radio club in July, I think.
Mm-hmm.
So do you remember what the one that Bill was going to do? Is he doing one beginning of June, I think?
I don't remember.
Because he was hoping that we would actually have hardware by then. And of course, all this nonsense going on.
Yeah. I know. So you still so the FPGAs are still the things that are holding everything up, right?
The FPGA and the USB 3 chip and the oscillator, but the oscillator's been ordered. Probably, everybody has their procedure it has to go through. So since we're ordering it as a how you call it, on account, basically, then they've got to get all the data for us. Like you got to get our tax number, and they got to get our Dun and Bradstreet references and all that stuff to make an account for us at Microchip. And so that's ongoing right now, but the parts are in stock. So so the 30 parts that we need to get this going, we're going to get within a couple weeks.
That's good.
And so
it's just the FPGA.
The FPGA and the USB part, and like I said, the USB part I could maybe do without if I had to, the first one.
Right.
The FPGA obviously can't. So that's going to be a holding factor. And they're driving me crazy because they just move at a snail's pace.
Yeah.
And I just can't seem to get them. They have no feeling of urgency whatsoever. Tomorrow's just as good as today. We don't care if it takes extra time. And, they say, well, they're on order. We want you to know they're on order. And I go, you actually don't understand, because unless they actually appear on the books,
it doesn't.
My rep can't go in and expedite an order that doesn't appear on the system yet.
Right.
So you can't just tell me, yeah, it's been entered. Well, no, it really hasn't been entered if he can't see it.
Right.
So that's kind of where we're at right now. Is I don't really have any choice. There's only one source. I could only push it after they get it on, online, so to speak. But once they do get it online, then we're going to be really ragged on them to deliver.
Right.
And so, but I just don't have a good feeling at all. It's been so long since I've ordered parts, these kind of parts, because these are fastest, biggest. These are the choice premium part. I didn't get a run of the mill everyday part. So it's not the same as ordering, a grade 8 commercial. We're grade 6 industrial. Well, that's the highest on the ladder. So it'll depend on how many other users use that part, whether they can shake a few loose from those big orders. I just can't believe you can't get me prototype quantities. I mean, they know how it works. If I don't prototype it, I don't produce it in volume. Simple. If I can't prototype it, I can't productize it.
Yeah.
So I don't know.
Oh boy.
And of course, the good news is we have all the other parts in boxes sitting in the other room.
Yeah.
So I should have no issues once we get that Intel part.
Yeah.
Because all the other parts we've managed to scrounge.
And then is everything are all the design documents all done up then?
So the documents are not yet, and the designs actually aren't, because the on the data engine, the CAD guy now he got everything connected up with the new Ethernet chip. He got that done last week. This week he's got to go through and he's got to length match all the differential traces. Well, not all of them, but he's got to length match certain ones. Like for instance, the ones going to the Ethernet RJ45s, they need to be all the same length.
Yeah.
And then the ones from the FPGA to the RFM module. Okay, the receiver, the lengths on the receivers, I want them all the same length too, if he can do it. And I think he can. And then on the clock module, I want all the clocks to be the same, all the output clocks to be the same length, because it's a minor detail, and we may not be able to keep synchronicity anyway, but I really want them to be synchronous so that they really are synchronous. So I want the clocks to arrive at the two modules at the same time.
Right.
If we can do it.
Right.
And if we can't, well, okay, at least I can get the clocks and the data lines to line up on one connector, because really between the two, it's not that important, but the clock versus the data. And the problem is I can move the clock around, okay, to increase the setup time or the hold time. So you increase the setup time at the expense of the hold time, or vice versa. But I can't move each individual data line around. So if I make sure the data lines are all the same, then that means they will all be in tune at the same time.
Right.
By moving the clock in position X, that will give me the same setup time and hold time on every one of the 14 data lines. So I don't individually move the data lines around.
Right.
So that's the thing he's going to do next. And once he's done that, then we got to go back and we got to substitute the new clock into the clock module. That should be easy because the new clock's smaller than the old one. So that'll be just almost a no-brainer change. Then I want to go through and update the capacitors per John's recommendation. And then I think we have to put a couple level translators on the RF board for I2C port. An I2C port we have to change to a different level because of the way we ended up having to clock the data. And then we're ready to do serious checking. And I think, maybe if we got some people on the list who want to burn their eyeballs out, we'll send you the schematics and have you say, okay, now I'm plugging that RF board in here, compare all those pins and make sure I got them lined up on the data engine the same as they are on the clock on the RF module, because all we need is one to be off. And the problem is we've changed the pin out a couple times on the RF module for routing reasons. And so I've gone back and updated the data engine, but always room for mistakes when you make a change like that. So you want to check it thrice and build it once.
Yeah, absolutely.
So, I mean, especially if you've got students with some free time, maybe this would be a good opportunity for the FPGA guy, because it is an FPGA board. I mean, it's not just writing code. You got to know how to connect up the FPGA.
Well, he would be the one that I think we'd assign to that.
So I would like to have him look at that, because the problem is that I don't really have anyone else who is experienced FPGA guy to double check. And I don't like that. I mean, I may not, doesn't matter how good you are, how many of them you've done, you can always make mistakes.
Yeah.
And to have another set of eyes look at it who's experienced is always good.
Yeah. Well, we
And
can
even if they-
certainly,
Yeah, even if they
have
aren't,
them look at it.
yeah, like even if they aren't experienced, my philosophy has always been that you are not likely to find a subtle error in my schematic, but you are likely to ask a question that shows up the subtle error because you just want to understand how it works, and then I'll go, oh, I didn't think of that, and then I'll go back and then I'll find a problem and fix it.
Yeah. Yeah, I think Kung would be good for that.
Yeah.
Yeah.
And especially he likes hardware, right?
I think so.
So he
Yeah.
wants to be designing boards as well as just writing code for them, right?
I think so.
Okay, well, this would be good experience because in my experience, the board designers are a lot rarer than the FPGA designers,
Yeah.
the coders.
Yeah.
But gotta have good hardware. And
Yeah.
I've seen some development boards that are not very good.
Mm-hmm.
They would not pass muster. Like David, you could appreciate this. We had the one board where they would take two bypass caps and they'd share a ground via, which is not fatal, but it is not good practice to do that. You really want two vias per capacitor, not 1/2 of a via per capacitor.
Right.
Yeah.
And our CAD guys figured out a way to modify the pad of the capacitor such that you can put it on the back and right adjacent to the power and ground pads. So I mean, it's got basically no trace length. It sits right on the pads. It doesn't really sit on the pads because we don't do via and pad, but it's got a trace that is so short that it's almost like the two vias meeting.
Yeah.
Right? There's almost no trace length. And so you get the best effectivity of your bypass caps by doing that.
Yeah.
Get them as close to the pads as you can.
Yeah.
And he's good at this. So we looked at the power supplies last time, and I think John was impressed that he did some pretty good layout work on the power supply, the switching power supplies. You get all the components just cheek to jowl, where they got almost no traces in between. You put a strip down here, and that's the ground, and all the caps hang off of it. And there's vias in it to the ground planes inside. So he's done a couple of these before.
Yeah.
So that's why I like using him, because I don't have to give him a lot of guidance on the art of stuff because he already knows it.
Yeah.
So he comes up with the first pass and it looks really good. So
That's great.
I can come up with some tweaks, but usually he's pretty up on it.
That's really good.
Yeah. So
I better sign off here. I'm starting to fade.
fall asleep.
And I still have to send more emails out to make sure all my students know where they're going tomorrow and what they're doing and all that jazz. And
So
I'll
is tomorrow
send
summer classes or something? What?
I'm doing a kickoff of the summer research program. So I have like 6 or 8 students, depending on how you count them, working on summer research projects. So Kung is one of them. And
it's Kung, K-U-N-G?
C-U-O-U-C-U-O-N-G.
Oh, he's been here before, hasn't he?
Yes.
Yeah, okay.
Yeah, you've met him.
Yeah.
So he's been here before, so he should be here again. So he's one of the students working this summer. And so I've got enough of them that I have to kind of actually make sure this is well organized.
Otherwise it turns into a disaster, right?
Yes. So I have like a packet written up explaining things, and I'm scheduling students and all that stuff. So yeah.
All right. Well, good luck with that. It sounds like fun.
Thank you.
Get some progress over the summer, right?
That's right. Absolutely. So thank you, Scotty, David, Michael, everyone else, Jonathan, Dan,
7-3,
Joe, 7-3.
7-3.
Thanks, everyone.
Yeah, I think it's time to QRT.
Yeah, I do too.
Good night.
Good night. Dan, if you're still there, we'll see you tomorrow.
Okay, Scotty, I have a question. I can't find the info that you sent me about sending out the invites.
Oh, maybe because I didn't send it to you. I think didn't I verbally give it to you?
No, I don't think so.
Okay. Well,
I know we talked about it and I expected to get an email and I didn't really look right away, but I looked a couple of days ago and I couldn't find it.
Okay, well, let me call you on the phone. That's probably the easiest
Okay,
way.
alrighty.
Okay.
Okay, talk to you
Bye.
later. Bye.
7-3, everyone.